In this video, I am going to illustrate the solution to an AP calculus exercise. So you may be given something that looks like this. It will be an integral, and maybe between limits such as 1 and 2, and f of 2x dx. So notice first that you are not given a specific function for f. All you are told is that you are composing f with the function 2x. Then you may be given some choices. For example, 1/2 of big F of 2 minus big F of 1. And you are told that the big F here is an antiderivative of little f. Or you may be given another choice, such as 1/3 of f of 2 minus f of 1. So one more time, this is the integral. The big f's are the antiderivatives, or some of the antiderivatives of this function little f. Now the question is, how do you work this exercise? Well, here, believe it or not, this is a disguised u substitution. And it takes the following form. Take a look. You let u equal 2x, the inner part. Then du equals 2 dx. Now you return to the original and you replace. And if you like, you can also change the limits of integration. So the function now will look like this. You can change the lower limit of integration by doing this. U equals 2 times 1, which is 2. The upper limit of integration you can change as u equals 2 times 2, which is 4. Okay, so we have switched from x as the variable to u as the variable. And the limits have been adjusted accordingly. And how do you adjust them? Well, if u equals 2x, then when x is 1, u is 1. When x is 2, u is 4. And you place in the new limits here. And then the inner portion will be written as f of u. And then dx can be replaced with the following. Solve this for dx. du over 2 equals dx. So you replace dx with du over 2. As follows. Now the 1/2, or as you should see it here, can be factored. So it's 1/2 of the integral between 2 and 4 of f of u du. Now we can work this. Little f has an antiderivative of big F. So we apply the following. Keep the 1/2 out. Anti-differentiate little f, getting big F. And then evaluate that between the limits of 4 and 2, so we'll give big F of 4 minus big F of 2, and place this within a parentheses. And then this is the exercise and details step by step, and also the solution, which is this right here. Okay. So depending now, of course, on the specific form of little f. Okay, we don't know what that is, however. So all you can say is that the solution is this quantity here. So one more time, this is what you will see as the question, or something like it. Then you will be given answer choices that look like this, or maybe an answer choice C, such as big F of 4 minus big F of 2, or maybe 1/2 of big F of 4 minus big F of 2. And then to solve this kind of exercise, you have to recognize that this is really a u substitution. So you let u equal 2x. You then let du be 2 dx. You solve for dx, so that dx equals du over 2. Then you go to the integral and you make the replacements. Where you see 2x, you replace it with u. Where you see dx, you replace it with du over 2, as I've done here. Where you see 1 as a lower limit of integration on the x, you replace that with 2 times 1, which is 2. Where you see 2 as the upper limit of integration, you replace that with 4. 2 times 2 is 4. Then du over 2 really means 1/2 of du, so you pull 1/2 out, as I've done here. Then you anti-differentiate, getting big F, an antiderivative. Then you plug in the upper limit and the lower limit, and you end up with this form. So if these were the answer choices, you would mark D as the correct choice. Okay, 1/2 of big F of 4 minus big F of 2. And if switching the limits is a little unclear, keep in mind the following. Let's draw a pictorial representation. Say this is our original function, and we are integrating here from 1 to 2, okay, this area. Okay, when you switch to the new limit of integration, that 1, the lower limit of integration, has to be changed accordingly. Okay, so this is the x-axis, and this is f of x. This is the u-axis, and this is now f of u. Right, so you have two different variables. You have to switch the limits accordingly. So that 1 is transformed. You feed it into u. Okay, so u of 1 equals 2 times 1, which is 2. So you transform that into 2 on the u-axis. Then 2, okay, the upper limit of 2 on the x-axis transforms into an upper limit of 1, 2, 3, 4 on the u-axis, okay, like this. And this is transformed by writing u of 2 equals 2 times 2, which is 4. And then the function also looks a little different, perhaps. But what you have to understand is u substitution, transform the limits, then it becomes a function of the variable u, and then you anti-differentiate and plug in, as I've done here. So this is an exercise of the kind you might see on the AP calculus examination. Thank you for watching.